In computing, logic forms the foundation of decision-making processes within electronic systems. At its core, logic in computing involves the use of Boolean operations, which process inputs to produce outputs based on specific rules. This is achieved through devices known as logic gates, which are the building blocks of digital circuits. Logic gates take binary inputs, represented as ones and zeros, corresponding to the electrical states of high and low voltage, and perform a Boolean operation to determine the output. There are three main types of basic logic gates: AND, OR, and NOT. Each gate performs a distinct operation. The AND gate outputs a 1, true, only when all its inputs are 1. If any input is 0, the output is 0. The OR gate, on the other hand, outputs a 1 if at least one of its inputs is 1. It only outputs 0 when all inputs are 0. The NOT gate, also known as an inverter, is unique because it only has one input. It outputs the opposite of the input, turning a 1 into a 0 and a 0 into a 1. These three gates form the basis for more complex logic gates, such as NAND, NOR, XOR, and XNOR, which combine or modify the behavior of the basic gates to produce more specialized functions. Logic circuits are constructed by connecting multiple logic gates together. By combining gates in various ways, it is possible to create circuits capable of performing complex computations and decision-making tasks. For example, a circuit designed to add binary numbers may use multiple AND, OR, and XOR gates arranged in a specific pattern. The outputs of one set of gates often serve as the inputs for another, allowing the circuit to process a sequence of operations. Such circuits are used in everything from simple devices like calculators to the intricate processors found in modern computers. One important aspect of logic circuits is that they are not limited to having only two inputs. While many basic examples use two inputs for simplicity, logic gates can handle 3, 4, or even more inputs, depending on the requirements of the circuit. For example, an AND gate with 3 inputs will output a 1 only if all 3 inputs are 1. Similarly, an OR gate with 3 inputs will output a 1 if any one or more of the inputs are 1. Increasing the number of inputs expands the gate's functionality, making it possible to handle more complex logical conditions within a single gate. Through the use of logic gates, digital systems can perform a wide range of tasks by interpreting and processing binary data. From simple decision-making processes to the execution of complex algorithms, the application of Boolean operations through logic gates and circuits underpins the functionality of virtually all modern computing devices.